welcome back to the course on engineering metrology. So this is the third part of the lecture on statistics for metrology fundamental concepts. So I took the fundamentals of statistics as requested by some students in the feedback, and in this lecture I would just try to explain or take the data visualization that I showed you in the previous lecture. I would just like to take that to the Excel file and like to show you that how does it work. So let us come to the Excel file. So these are a few data that I have selected for X bar and R chart, P chart, C chart. These charts would be covered when I will cover the quality control. However, how to plot the charts, the diagrams or the figures or the illustrations that I discussed in the previous lecture. So I discussed about a few data visualization or a few charts such as bar charts, histograms, then pie charts, scatter plots, line charts, bubble plot, then box plot, and so on. These were discussed. So I like to show you how these are plotted here. This is just a data set in which these are the subgroups. So T1 to T15 are the subgroups, and 4 or D5, 5 readings are taken. This is the diameter of the shaft, and 5 readings are taken at 5 different locations, and this is the output that has come. So I will explain the data set more when I will discover the quality control or the control charts. You know, you can see the name, it is made for the X bar and R chart. So first I like to show you how do we construct the bar chart. So, you know, the first thing is I go to insert tab in my Excel window, and you can see the various options here. We can insert the charts and filters, links, and so on. Many things can be inserted here. First I will go to charts here. There are certain recommended charts. Those are just put here in the front face here. So I will just click this bar or the columns. So it is showing, okay, 2D columns, 3D columns, 2D, then horizontal and vertical columns. So as I said, there are two kinds of bars. One is stacked bar, another is spread bar. Spread bar is when it is spread. It is like I showed the height and weight in the previous lecture. Stacked bar is when it is stacked over each other, when one height can be added to the other height. So those kinds of plots can be made here. So let me pick this column. I just select the column and go to my chart and just click this thing. Now this chart is selected. It has plotted these values. It has plotted these values. This 1 to 15 is the number of observations. You can see there are 15 observations. 1 to 15 is the number of observations, and this is the value for the first, second, third. If I go here, I can see, okay, this is series 1.1 value, this one. So if I like to edit this thing, I can, if I like to see the values here, I can just say add data labels. Data labels is the value of the data that would be represented on the chart itself. So data labels can be added, add data labels. So it is now showing the value. 28.9 is the first observation, okay, 28.4, 32.2, these labels are being shown here. So this is just one series. I have selected one column and it has just spread that bars. Now I can select two series. Okay, let me select the first row as well, D4 and D5. Now it will try to show the name of the series as well. You can see here it is trying to represent it in two different colors, okay, blue and orange. So blue is D4, it is showing here. This is what we call, in general we call it as a key of the chart or maybe key of the map sometimes. So this is known as legend here. This D4 and D5, this is known as legend here. So we can even edit the legend if you like, format legend. We can change colors, we can keep it at top, we can keep it at bottom, left, right. If for instance, if I just keep it at right, and I can even put some colors, etc. Like I showed, two requirements are there in data visualization. Number one is functionality. Functionality is which kind of chart should we select to properly fit the data. Number one, this is function. Okay. Number two is aesthetics. In aesthetics, we can think of different colors and whether the chart looks appealing to the eye or not. Those things can also be thought of. Whether does it fit properly in the report or not. So these two legends. Sorry, this legend is one legend is there, and these two data series are there. D4 and D5. D4 is this column, and D5 is this column. Similarly, I can plot all the 5. Insert. So this is my bar chart. If I expand it, you can see it is also expanded. So this is the kind of a spread bar. Okay, this is kind of a spread bar. Also, I can have stacked bar. For instance, if I pick this Excel sheet will actually we share with you, and if you like to see, you can see the charts are actually placed over each other. You can see these charts. Okay. So if I select these two columns and then insert chart and I select this thing, this is a kind of a stacked bar chart. So one value or one series is stacked over the other series. So this is the data series, this whole this column. So I can even show the labels here for the specific these values, add data labels, and I can even get the data labels for the blue one as well. So D4 and D5 are being shown, and it is stacked over each other. So again, the stacked and the spread kind of bar charts. Also, we can have these in the horizontal direction as well. So that is your choice, where if you what the way you would like to present the data. Like in time series, sometimes if you need to show that okay, there is a time plot as well. It is the first reading, second reading, third reading. It is better to keep the time or the order in the x coordinate only. Okay, so otherwise you can pick these as well. Okay, so these are the values. These are the spread bars in horizontal direction. So this is the bar charts. We'll use the X bar and R chart. X bar chart, actually we won't, X bar and R charts are control charts, but we'll plot a line diagram there. So I'll come to line diagram again. So next chart I will have to show, similar to bar charts, is the histogram as I showed. Histogram, what does that show? If you could recall, histogram shows the frequency of the occurrence of some specific range or some specific value. Okay. So if I try to plot histogram here, okay, this here we have histogram here. Also you can see all the charts. If I open this one, you see I have clicked this button here. It is opening charts, all charts. It is showing bar, area, scatter plot, surface, and we'll just cover a few out of these, and I can pick histogram from here. Okay. It is now showing the values between certain ranges from 25.2 to 30, 30 to 34.8, 34.8 to 39.6. It is the value for this series D4. Okay. So it is showing that from 25.2 to 30, there are about 7 observations. There are total 15 observations. So 7 plus 6 plus 2 is 15. So it is showing the frequency of occurrence. So this is the way histogram is plotted. As I said, histogram, when you have to print it, for instance this chart, sometimes you can find this kind of chart, this chart, stack bar chart. This spread bar chart, for instance, it is there. So there were 15 observations. Had it been maybe 50 observation, 50, it wouldn't look very elegant when it is presented on a paper. So as I said, there are certain tips when we plot a chart or a histogram. It has to have about from 3 to 13 bars. It can have more bars, but 3 to 13 is a good number to be selected. It has to be fit into the paper. When you print it out, it should be legible to be read. Then certain other observations, as I said, that other tips are important for selecting the chart. For like intervals are to be defined. For instance, I didn't pick any intervals, it picked the intervals by itself, but we can also define the intervals here. So it has to be comparable with other graphs. These things were important, as I said. So this is the histogram chart. Okay. Next, I'll come to the Okay, I'll pick the pie chart now. Let me pick some other data. This is the data set for the proportion of defective sets. So I'll try to plot, okay, no, C chart, okay. I'll try to plot the pie chart now. Let me pick first 5 values, okay. These 5 values, if I go to insert here, pie chart is directly here on the front end. If I just put the pie chart, it is showing the different, it is showing that, okay, this is 1, 2, 3, 4 and 5. It is showing 1 is this much area, 2 is this much area. You can see the maximum number is 1, 27. So this 1 is this much area. Okay, let me add labels to see the actual size of each pie. So this is 27 units, this is 23 units, 17, 20 and 17 units. So I can edit this pie chart. For instance, if I even select all the points or the full complete chart, I put pie explosion. Pie explosion will just expand the chart to some extent, okay, 55%, 8%, or even if I need to show some specific reading, okay, this is the maximum reading, I can just pick one and then explode that. Now it is exploding only this reading 27, okay, this is the maximum number of units. Even in place of the number of units, we can also have the percentages here. This actually pie chart is the 100% complete values are there. The first 5 values I have picked and the whole values are there. As I said in the previous lecture, that we cannot cheat with the axes, we cannot cheat with the scales in case of pie chart. So this is actually the some percentages there. It is better, some people like to present the data in percentages. So I can even edit the data labels. So I will go to format data labels and add percentages. So these are now percentages. Actually, it is very close to. I think the whole sum would be very close to 100. So this percentage 27. It was the number was 27. So it is the percentage is also close to that. So let me say what is the sum of these things. Let me say this is equal to sum of. Okay, the sum is 100, it is close to 100. Or let me pick the 6 values and then plot a pie chart. Okay, let me have 3D pie this time. So let me add labels, data labels. So it is showing the numbers here. So I can edit or format the data labels and add percentages. Now it is also showing the percentages here. Okay. So this is pie chart. How do we plot the pie chart? Similarly, we can pick any kind of chart and plot the next chart. I would like to pick a few. Okay, very important chart is scatter plot. So let me pick some data and try to see the scatter plot. Okay, that I will use here only. So scatter plot is very important. As I said, the correlation or the trend is shown in the scatter plot. When we have two different values like height and weight, then we had hardness and wear. Those can be compared. The scatter plot is very important to compare. These are actually diameters. So let us see whether the diameters of the test 1 and test 2, how do they correlate? So this is a scatter plot that is also kept here. So I'll just plot this scatter plot here. So these are 5 points. So it has taken T1 on this side, edit axis, format axis. Okay. The one thing is this axis has the x coordinate has started from 0 to 35. However, no value is lower than 25. So I can vary this value as well. So let me edit this axis. It is 0 to 35. I'll take it from 25 to 35. Okay. So it is showing better. So okay, I can even add a trend line here. Add trend line. It is kind of showing a trend, that this kind of trend, a positive trend is there. However, this is if you actually see the correlation, this is not a very great or very strong correlation. So, but some trend is there. Some trend it is showing that the positive trend is there. So let me try to plot some more values. Let me try to plot these values here in a scatter plot. So, you can see the values, all the values are greater than 20 from extraordinary, all the values are greater than 25 here. So, I can edit the axis, format axis. This is 0 to 40, I will start it from 25. Okay. Now, this axis I will also format. Right click, okay, select axis first, right click, format axis. I will start this from 20 maybe. Okay. So, this is also a kind of a very poor correlation, but let us see whether there exists some better trend or not. I will select the data and add a trend line. So, yes, it is again showing a trend line. Also, if I need to add a trend line can also be formatted. This is just a linear trend line. I can add exponential, I can add some other function, some other mathematical relation. The trend line can be moving average, or like those are the things actually which are out of scope of this course. But yes, exponential, if I add exponential, it will show, it will take exponential function and then add a trend line. So, the best way at this point of time, it is better to just plot a linear trend line. So, it is also showing this thing. Similar to the scatter plot, if we have a third dimension, I have picked some data from the available data set of Microsoft to represent the bubble plot. So, we can plot the bubble plot as well. So, bubble plot is not kept on the front face because that is not very frequently used by the people. So, I can just go to all the charts, all charts, and pick bubble plot here. Yes, bubble plot is there in the category of scatter plots only. So, I will pick these 3D bubbles. Okay. Now, what is this chart representing? So, this is actually number of products which are produced by a company. Okay. This is the sales. So, this is the percentage of market share this specific product has. Okay. Now, it is showing 3 dimensions here, 0 to 30. 0 to 30 is the number of products. Okay. 5 products, 14 products. Okay. Then 20, 18, 22, 5, 14, 20, 18, 22. Then we have this sales. Limited sales, and these sales here are from $5,500 to $32,000. Okay, these sales are here. What is this size of the bubble representing? It is representing the market share of the specific product that is having. Okay, in metrology we can pick. Let me say, if I am trying to compare the length and diameter and number of the pieces which are inspected. So, number of species that would show the size of the bubble, and length and diameter can be represented in the simple x and y direction in both these axes. So, this is when we need to show, or when we need to present the 3 dimensions in one of the 2D plots. So, this is bubble plot. Okay, I can even box plot was also discussed in the previous lecture. Box plot is if I have this, okay, let me first plot the line diagram. Let me pick any chart here. Let me pick any chart, and I'll first plot. I'll pick first trend readings and add a line diagram. So, it is showing if the data is continuous. Okay. So, it is better to represent in a line diagram, and this we will use very much in our control charts. So, the data, the first data point is 19, 27, 28, it is being representing in a line. So, I will just add the data labels here. Okay, these values are showing. So, this is our line diagram. Okay. So, we can have various variables in line diagram. We can even have these points here. For instance, if I have 2 lines, let me plot these 2 lines here, and you can see that these two lines are presented. Even these points, the data labels are to be added, number 1. Okay. I can even, if I have these lines, number 1, it is differentiated by the color, blue and orange color. Okay. The last chart I'd like to show here is the box and whisker plot. So let me pick these 11 points here. I picked 11 points because I would like to show you the median here. So insert, go to all charts, recommended charts in all charts. So there in all charts we have box and whisker. So this box and whisker plot is there. Okay. So I can have many box and whisker plots like this. If you remember box and whisker plots, the center line was our median, and we have quartiles, first quartile, then median, then second quartile, and we have maximum and the minimum value. You can see out of these points 19 and from 19 to from period number 1 to period number 11 I have selected actually. So the minimum value is 15 and the maximum value here is 31. So it is representing 31 here and 15 here, the minimum value. This is the median value. Median value is the center value. Center value is close to 27 or something. Okay. So this is box and whisker plot. These two are whiskers. This is quartile 1. This is quartile 2 or median. This is quartile 3. This is the minimum value. This is maximum value. So I can have, you know, if you see the all charts here, there are number of charts that we can plot. We can have even have this surface diagrams, like in bubble plot we have the third dimension. In surface diagrams also we can have the third dimension. The 2 dimensions are there. So this is a 3D representation. There are number of charts which are there, and Excel is having a great capability, and it can help us to plot many. There are other design softwares as well. When we design for the experiments, it is known as design of experiments, and we select the specific number of experiments. Those are to be conducted in metrology when we do measurements. So there are number of plots that we can use to represent our data. So this was about the fundamentals of statistics in metrology. So in next week we'll meet and discuss more on statistics in metrology. Thank you.